So welcome to section number 3. Now for the first time we are really going to generate some output. This output may not be very impressive first of all, but it's our first step to really have a visual impression of what Vulkan is doing for us. So in this section I want to guide you through the following things. We are going to combine the code that we have produced before, and we are going to use the VK clear color to get a red background color in our window. So in this video we are going to bring together the pieces of code that we've done so far. It was a bit nasty till that point, but now it will make sense. So let's bring the code together. What we want to achieve in this video is this output of the window with the red background. This will be really our first Vulkan window holding some rendered information. Although it's just a simple red background color, it really gives us an idea what steps we need to take to create an output on the screen. So now for the first time we are going to work in the function Vulkan render, the function which is called every frame to render our result to the screen. So let's take a look at the steps we need to take here. First of all, we need to get the proper output image that we can render to. So we are using the function vk acquire next image, and we are passing the device, the swap chain, and a handle to a variable to store the index of the image that we can use for this frame to render our data to. Next, we will start to record our first command buffer. So as usual, we are creating a struct to hold the information what we are going to do. So we are creating a vk command begin info. So we are starting by creating a vk command buffer begin info struct, and just as usual we are setting the s type to the proper type. Now to set the red background color, we need to bring in a so-called clear value. So within the function vk begin command buffer, passing the draw command buffer that we've created previously, and passing the begin info we already created, we are ready to bring in some values. First of all, we've got these 4 values, which are R, G, B, and alpha value for the so-called clear color. This color is used to overdraw every result of a previous frame with a given color, so we can start from blank and draw over the background color again. So in the end this clear color always somehow feels like a background color. Additionally, we are setting a so-called depth value and a stencil value, but we don't care about this one later, just place the value here. We may make use of this in a later section. Now it's time to set the information for the render pass. So we are going to create a vk render pass begin info. Of course, as usual, we are setting the type. And now we are passing the global handle to the render pass that we have already created. And we are passing a handle to one of the frame buffer images that we have created as well. So you see now all it's adding up. All the global variables that we've defined and set before are coming in here for reuse. To set the area of the screen, or to be precise, the area of the window in which we are going to render, we need to set a render area. This is defined by a starting point, somewhere on the lower left, giving a dimension in width and height, and summing this up to a rect. So we are passing this rect to the render area of the vk render pass begin info. Of course, we have the clear values here as well, which we've defined previously, and we are passing those to the info structure as well. Now that we've got all the information for this render pass, we can use the function vk command begin render pass, again giving the handle to the draw command buffer that we've created previously, and giving of course the handle to the struct that we've just created, holding all the information about the render pass that we've created right now. So now you really see that all the nasty code that we've done before was just to be reused for now when we really start the actual rendering. So here's the point that we leave blank for right now, because at this point actually we would bring in the actual draw commands, but we will do this in a later section. For now we are only fine by setting the background color and drawing the screen with this red background color. So after we've done all the drawing later, we will call the vk command end render pass, passing again the handle to the draw command buffer, just to stop the recording of the command buffer. So now that we've got the proper settings for the render path and the proper settings for the command buffer and the command buffer being ended, we need to submit this data to the queue that we've already created previously. The queue will then execute the commands on the GPU and create the visual result. But here's the problem. We need to know at what point the GPU has done its work and we are ready to present the final image. For this reason, we need to create a VK fence. The fence will inform us as soon as the GPU has done its work and we are ready to present the final image on the screen. So let's create a fence. As usual, we are creating a structure holding some information. This time it's pretty simple. It's a VK create info, and we are setting the S type. With this information, we are ready to VK create a fence. Again, we are passing our global device. We are passing the fence info structure, and we are passing the render fence variable that we've created before. To be able to submit now all this information to the queue, we need a VK submit info structure again. As usual, we are setting the S type, and now we are setting some more values, summing up again data that we've already created before. We have created one command buffer, so we are setting the count to 1, and of course we are passing a handle to this command buffer because the queue should execute our created command buffer. As soon as we've populated the VK submit info, we are ready to submit it to the queue. So we are calling VK queue submit, and we are referring to the global present queue that we've created as well previously. We are passing the handle to the infrastructure, and we are passing as well our render fence. Now the queue is ready to work, holding all the information that we have previously, and it also has a reference to the fence which will inform us once the work is done. So this is actually the next line of code. With the VK wait for fence, again referring to the device, deferring to the render fence, we just wait for the moment that the GPU tells us, okay, I'm ready with the work, you can go on. Because this is the point from where on we will take over again, because we want to present the render result on the screen. As we don't need the fence any longer, so we can just destroy it here, again referring to the device and the fence, so we get rid of it and we keep clean code. So the final step to take now is to present the already rendered image to the screen. We as well already prepared some code for this, so let's make use of it. First of all, we need to create a VK present info. So again, setting an S type, and now what is relevant for us is our reference to the swap chain that we've created previously and to the image that we have queried from the frame buffer to be populated during the render pass. With this information, we can use the VK_queuePresent function to really present our image on the screen, referring to our present queue and referring to the infrastructure just created. So this really takes the image which has been populated on the graphic card and will present it to the screen, making use of our created swap chain and making use of our frame buffers and holding the images created for the frame buffers as well. So in the end, submitting our recorded command buffer by the queue to the GPU and presenting the final image, we should get an output like this. Again, that's not very spectacular, it's just a red background, but for the first time you are really presenting a Vulkan rendered image on the screen. So congratulations, for the first time you really outputted information on the screen using Vulkan programming. Of course, this result is not very impressive, But I guess you understand by now the concepts that we need to take to get a final output.